Here is the very last example from your note packet. What is the volume of 5 kilograms of hydrogen gas at room conditions? The density of hydrogen at room conditions is 0.0899 grams per liter. This problem looks scary. It's using a lot of science vocabulary terms like hydrogen gas, densities, room conditions, but what we can do is we can use this GWR framework to help sort through the important information that will help us get to what we're trying to solve. So don't be afraid of the wordiness of this problem. I want you to make sure that you're using those reading comprehension skills and this GWR framework to help us find the pertinent information. So here we go. What is the volume? That statement alone tells us we are trying to solve for volume. A little tip I gave you before is that the given is usually the number that follows the want. So when you keep reading through the problem, 5 kilograms is the next number that pops up. So that's a good indication that 5 kilograms is a given. I can also recognize this is a combo unit. And with this combo unit, I can set that up as a ratio, 0.0899 grams per liter. Now, when I'm trying to make sure I have all the ratios that will help me get from my given to my want, I realize that I have grams here and kilograms here, and I realize there's a connection there. There are 1,000 grams per kilogram. But the other thing that that you might be wondering is, volume is not a unit. Volume is actually not a unit. So you have to stop and think, what is the most reasonable unit that we can set for volume? As we're looking at all the information that we're given so far, you might recognize there is a unit of volume here. Think, think, think. That unit is liters. So in reality, we are looking for a unit of liters to finish our problem with. All right, let's come back to this idea of kilograms and grams. We know there's a conversion, a ratio that will help us convert from kilograms to grams, and that conversion is that 1 kilogram equals 1,000 grams, or backwards. Doesn't matter, it's the same thing. This stepping stone will help us change from kilograms to grams, and this one from grams to liters. And look at that. We have everything we need. We took this problem that looks somewhat complicated and we simplified it by using this GWR framework and all those tips and tricks we've learned in between. So here we go. We have 5 kilograms over 1. I have kilograms in the bottom, 1,000 grams in the top. I have grams in the bottom, liters at the top. I used up this ratio just now. And now I have everything I need. I cancel out my units diagonally. It leaves me with liters. And in my calculator, I can type 5 times 1,000 divided by 0.0899. And my answer in my calculator might look something like this, with a unit of liters, of course. There's one missing piece that we want to consider before finalizing this problem, so I want to give you guys a moment to think about what that missing piece is. That missing piece has to do with sig figs. There is only one significant figure in the given, and we need our answer to reflect that as well. This is our one significant figure we are focused on, and since this 5 is sitting next to a 5, we're going to round this up to a 6. And we're going to turn all of these numbers into zeros and make sure we do not include a decimal point at the end. Our answer is 60,000 liters, and this is the volume or space, same thing, volume is a three-dimensional space, that 5 kilograms of hydrogen gas at room conditions would take up.